Hey there, welcome back to another Make Science Easy physics lesson. In this lesson, we're going to be learning about speed, velocity, and acceleration. We're going to be finding out what they are, and we're going to be looking at some examples, and we're going to be comparing them as well. So first of all, let's have a look at speed, and let's find out what it is. Now, in very simple terms, we understand speed as a description of how fast an object is travelling. So we can see here we've got some different objects: a snail, a cheetah, a race car, and a space shuttle. Now, all of these objects are going to be travelling at different speeds. And it's fairly obvious, of course, that the snail is going to be the slowest of all of these objects, and the space rocket is going to be the fastest. So this tells us a little bit about relative speed, but it doesn't give us enough information in a scientific sense. So we need to be able to provide suitable units to tell us the speed that something is travelling at. An average speed is defined as the distance an object travels in a period of time. So essentially, speed is distance per unit of time. So speed equals distance divided by time. And it's important that we use suitable units for speed. So for example, we're not going to use the same units for the space shuttle as we would do a snail, because the space shuttle is so many magnitudes faster than the snail that it just wouldn't make sense to use the same units. So for our snail, which is incredibly slow, it might be useful to either use meters per second or even centimeters per second. For our cheetah, meters per second or kilometers per hour. For our race car, kilometers per hour or meters per second. And for our space shuttle, we're going to use kilometers per second. Now you'll notice that all of these units are using SI units. So we have SI units for distance, or a derivative of an SI unit for distance, and we have an SI unit for time as well, or a derivative of an SI unit for time. However, meters per second is pretty much generally always the unit that's going to be most appropriate, because it includes two SI units. It includes meters and seconds. So where possible, we try and use meters per second, as it is nearly always the most appropriate unit of speed. Now, it's really important that we can also do calculations involving speed. And the three parts of our equation are always going to involve speed, distance, and time, because we know that speed is equal to distance divided by time. Or we can write S equals D over T. So either of these ways are absolutely fine. We've shown that speed is equal to distance divided by time. However, we sometimes are going to need to rearrange this equation, and so we can use an equation triangle to help us. Now, our equation triangle essentially works like any other equation. If we have something on top of something else, the number at the bottom is dividing the number at the top. If we have two units next to each other, then they are multiplying each other. So armed with this information, we can fill out our equation triangle for speed equals distance divided by time. So distance is going to go at the top of our equation triangle. And we know this because distance is divided by time. So distance must go at the top. This also means that time must go at the bottom of our equation triangle. This only leaves one space remaining, which must include speed. So, from our original equation, we can now see that it's possible to rearrange these equations. And we can see that time is going to be equal to distance divided by speed, because distance is also on top of speed. We can also see that distance is going to be equal to speed multiplied by time, because speed is next to time. So from our equation triangle, we can derive three different equations, And we can now calculate speed, time, or distance. So we can rearrange our equations. So let's have a look at an example. A car travels 30 kilometers in 2 hours. And we need to calculate the speed of this car. So the first thing that we always do when we have an equation is we write down the different symbols of the components of that equation. So we have speed, distance, and time, or S, D, T. We do not know what the speed is. This is what we're trying to calculate. So we're going to write a question mark next to it. We do know the distance because it's in the information we're given. It's 30 kilometers. And we do know the time, again, because it's in the information we're given. It's 2 hours. So we can fill out the information that we have and that we do not have. We want to find out what speed is. So we cover up speed in our equation triangle. And we are left with distance divided by time. So whatever you are trying to find out, whatever you are looking for, you cover up in your equation triangle, and it will give you the overall equation. So we now know that speed is equal to distance divided by time. We can then put our units into our calculation. So speed in this example is equal to 30 kilometers divided by 2 hours. And this is going to give us 15 kilometers an hour. 30 divided by 2 is 15. Kilometers divided by hours does not resolve, so we're left with kilometers per hour. So our unit is also derived from the information that we are given in the equation. I just want to take a little break in this lesson to tell you a little bit more about Make Science Easy, and you can visit us at makescienceeasy.com. At our website, makescienceeasy.com, we have complete science courses for biology, chemistry, and physics. These are just like this lesson, but in lots more detail, covering everything that you need to know to pass your science exams. Every course, so the biology, the chemistry, and the physics, has over 65 lessons to it. Every lesson also includes printable resources, question and answer sheets to make sure you've understood, and multiple choice quizzes that you can take online, and you get an immediate grade to see how much you've understood and if you've really learned the concepts. If you want to sign up for Make Science Easy and get access to all these lessons, there is a free trial, but at the checkout, if you want to purchase full access, you can save 50% by entering the code YT50. So we've got another example here. We're going to be calculating something different. And this time we're going to be looking at a runner who runs 400 meters in 65 seconds. And we need to calculate the speed of this runner. So we've got our information, speed, distance, time, and we need to put our numbers in. So we don't know speed, so we put a question mark next to it. We do know distance, it's in the information, 400 meters. We do know time, 65 seconds, again it's in the information. So we now have the key information. We need to calculate the speed, so we cover it up, and we're left with distance divided by time. So speed is equal to distance divided by time. So speed is equal to 400 meters divided by 65 seconds. 400 divided by 65 is 6.15. Meters cannot be divided by seconds, so we have meters per second as our unit. So speed is equal to 6.15 meters per second. Okay, let's have a look at a third example just to make sure that you really understand this. So this time we have a plane traveling a distance of 4,000 kilometers, and we have a speed of 800 kilometers an hour. This time we're not looking to calculate the speed, we're looking to calculate something else. This time we need to calculate the time that it takes this plane to travel there. So just like before, we write down the components of our equation: speed, distance, and time. We write down the speed, 800 kilometers an hour. We have that information in our question. We write down the distance, 4,000 kilometers. Again, we have this information in the question. and we write a question mark next to time because we do not know the time. This is what we're trying to calculate. So we go to our equation triangle and we cover up time because this is what we're trying to find out. And we're left with distance divided by speed. So time equals distance divided by speed. We then put our numbers into our equation. Time is equal to 4,000 kilometers divided by 800 kilometers per hour. Now, what's very, very important here, unlike the previous equations where the units did not resolve, here the kilometers are being divided by kilometers, so they cancel each other out. The units of kilometers, because they are dividing by each other, cancel each other. So we are left with 5 hours. 4,000 divided by 800 is 5, and kilometers divided by kilometers per hour is hours. So this plane takes 5 hours to travel 4,000 kilometers. Okay, so we're going to have a look at one more example of these speed calculations just to make sure we've really understood. So, a tortoise moves at 0.3 meters per second for 15 minutes. Now, that's a pretty fast tortoise, but that's okay. It's just to illustrate a point. So we need to calculate how far this tortoise actually travels. So we do what we've done before. We take speed, distance and time, and we put the information that we know into these numbers. So speed, 0.3 meters per second. Distance, we don't know, and time is 15 minutes. Now there's something very, very important here that you have to notice and you have to recognize. The unit of speed is in meters per second, but the unit of time is 15 minutes. Now it's very, very hard to work with units that are different to each other. So you need to essentially make sure that the units are the same for speed and time. And this is why we have our SI units. These are our standard units that we want to use. So because speed is in meters per second, we want to convert time into seconds as well. We know that there are 60 seconds in a minute. So if we multiply 15 minutes by 60 seconds, we are left with 900 seconds. So there are 900 seconds in 15 minutes. So this is the unit that we're going to be using. 900 seconds, not 15 minutes. So we now do what we've done every other time. We cover up what we're trying to find out. So we cover up distance and we're left with speed multiplied by time. So distance equals speed multiplied by time. We put our numbers in. Distance equals 0.3 meters per second times 900 seconds. Now the seconds are going to cancel each other out here because we have meters divided by seconds multiplied by seconds. So these numbers cancel each other out and we are just left with meters for our unit of distance. So 0.3 multiplied by 900 gives us 270 meters. Okay, so we've mentioned what speed is, and we also said earlier that this lesson is about velocity, and people often confuse speed and velocity, and people sometimes think they are the same thing, and that is not the case. Speed and velocity are used interchangeably, and in everyday language this is kind of okay. For scientific language, we have to be very, very precise with that language we're using, and we need to make sure that we use language correctly. So, although speed and velocity mean similar things, they are not the same in science. So speed is simply a measurement of how fast an object is travelling. And speed is an example of what we call a scalar. Now, what we mean by this, a scalar only has magnitude. So the speed of this car is 25 meters per second. We are only providing a magnitude of how fast it is traveling. Velocity is a measurement of the speed that something's traveling and the direction that it's traveling in. So velocity is an example of what we call a vector. Vectors have magnitude and direction. So for example, if we say this car is traveling at 25 meters per second to the right, we have a speed and a direction. So it is a velocity, it is a vector. Velocity is speed and direction. Speed is just speed and nothing else. So when we add a direction in, we have velocity, a vector. So vectors have magnitude and direction. So a speed and a direction. Scalars only have magnitude. Okay, so the next thing we need to look at is acceleration. And acceleration occurs anytime there is a change in velocity. Now remember, and this is really, really important, there are two parts to velocity, a magnitude and a direction. So anytime we have a change in velocity, we can either have a change in speed or a change in direction, or we can have a change in speed and direction. So acceleration does not necessarily require a change in speed, merely a change in direction. And we can calculate acceleration using this equation. Acceleration is equal to a change in velocity divided by time. Or acceleration, A, equals delta S, change in speed. Delta is a triangle, and it always means a change of, divided by t. So A equals delta S divided by t. Or even better, A equals V minus U divided by t. Now, when we say V, we mean the final velocity that something's traveling at. And when we say U, we mean the initial velocity that something's traveling at. So let's take an example of a car. This car has got a change of velocity from rest, and from rest always means 0 meters per second to 10 meters per second over a period of 20 seconds. So we do what we've done before. We take the parts of our equation: acceleration, final velocity, initial velocity, and time, and we put the numbers in. So we don't know acceleration. We do know the final velocity, 10 meters per second. We do know the initial velocity, 0 meters per second. And we do know the time, 20 seconds. And we can plug these numbers into our equation. So V minus U, final velocity minus initial velocity, equals 10 meters per second minus 0 meters per second, which is obviously going to give us 10 meters per second. So acceleration is equal to 10 meters per second divided by 20 seconds, which gives us 0.5 meters per second, which sounds rather clumsy, so we can say acceleration is equal to 0.5 meters per second squared. The unit of acceleration is meters per second squared. So let's have a look at another example. And it's really, really important to point out that acceleration also occurs when something slows down. Now, in everyday language, we say something is decelerating or it's slowing down. In physics, we do not use the term deceleration to describe something that's slowing down. We say that when something slows down, it has negative acceleration. So something that is slowing down in physics is still accelerating, because all acceleration is a change of velocity. If it has negative acceleration, it is slowing down. If it has acceleration or positive acceleration, it is speeding up. In this example, a car has a change of velocity from 10 meters per second to 5 meters per second. And we can see here that it takes 2 seconds for this change of velocity to take place. So we put the numbers in again. A, acceleration, we don't know. V, the final speed, is 5 meters per second. U, the initial speed, is 10 meters per second. And the time is 2 seconds. So V minus U equals 5 meters per second minus 10 meters per second. So the change in velocity or v minus u, is minus 5 meters per second. So acceleration is equal to minus 5 meters per second divided by 2 seconds, which gives us a rate of acceleration of minus 2.5 meters per second squared. Okay, so let's just have a quick look at some other acceleration problems as well. And when we're doing slightly more complicated acceleration problems, we might need to include an equation triangle, which works exactly the same way that we've used it before. But we might also need to include a little bit of extra information as well, but it's really not that difficult. So let's take a look at an example. So here we have a car traveling at 10 meters per second, and it's accelerating at a constant rate of 4 meters per second for 10 seconds. So we need to calculate the final velocity. So in order to calculate the final velocity, we know that the final velocity is going to be equal to the initial velocity plus any change of speed. And the final velocity, therefore, is going to be equal to 10 meters per second, our initial velocity, plus 4 meters per second, which is our rate of acceleration, multiplied by 10 seconds, because a change of speed is equal to acceleration times time. So 10 meters per second plus 4 meters per second times 10 seconds gives us final velocity equals 10 meters per second plus 40 meters per second. So our final velocity is 50 meters per second. So although it can be a little bit more complicated, it's still really just using the principles that we already know. So, in summary, speed is a measurement of how fast something is travelling. It is a scalar value, and it's generally measured in meters per second. And we calculate speed using distance divided by time. Remember, when we say scalar, we mean it just has a magnitude. Velocity is a measurement of how fast something is travelling in a specific direction. That means it's a vector. It's got a magnitude and a direction. Acceleration is a measurement of a change of speed over time. Deceleration is known as negative acceleration, and acceleration equals a change in speed divided by time, and the unit of acceleration is meters per second squared. So, I hope you now know a little bit about speed, velocity, and acceleration. Until next lesson, keep on learning.